Good afternoon and welcome to my viewers again. Today we'll discuss some more properties of whole numbers. We have already learned that the natural numbers together with 0, 0, 1, 2, 3, 4, 5, 6, etc. are called whole numbers. And we have also learned that product of any two whole numbers is a whole number. Say for example 6 5s are 30 or 5 10s are 50. Now this product 30 is called multiple of 6 and 5. 6 multiplied by 5 equal to 30. This is called multiple, and these are called factors. Factors of 30, 6 and 5, and multiples of 6 and 5, 30. Similarly 5 tens are 50. Now 50 is called multiple of 5 and 10, and 5 and 10 are called factors of 50, and 50 is called multiple. So product of any two whole numbers is called multiple of the numbers. Product of two whole numbers is 30. 30 is the multiple of 6 and 5, and 6 and 5 are factors of 30. Product of any two whole numbers is called multiple of the numbers, and numbers multiplied are called factors of the number. Now let's multiply the whole numbers by 2. 0 multiplied by 2, 0. 1 2 is 2, 2 2 is 4, 3 2 is 6, 4 2 is 8, etc. So when you multiply the whole numbers by 2, you again got a series of whole number: 0, then 2, then 4, then 6, then 8, then 10, 12, etc. Now this series is called even numbers. Even numbers. Now while multiplying these whole numbers by 2, you left out a group of whole numbers, means 1, 3, 5, then 7, 9, then this series is called odd numbers. So even numbers are multiples of 2 and odd numbers are not multiples of 2. Thus we broadly divided the whole numbers in two series. One is even numbers and other is odd numbers. Even numbers, the numbers which are multiples of 2, the whole numbers which are multiples of 2, they are called even numbers, and the whole numbers which are not multiples of 2, they are called odd numbers. We have already learned that whole numbers can be represented on the number line. It is starting with 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. Now you see the difference between any two successive even numbers. Say for example 8 minus 6 equal to 2. Successive even numbers 6 and 8, 8 and 10, they are successive even numbers. 10 and 12. Similarly 6 minus 4 equal to 2. Similarly 4 minus 2 equal to 2. The same way we can find the difference between a pair of successive odd numbers. Say for example 9 minus 7 equal to 2, 7 minus 5 equal to 2, 5 minus 3 equal to 2. So even numbers and odd numbers are equally spaced, means the interval is same. This difference between a pair of successive odd number is also 2, and difference between a pair of successive even number is also 2. Now why 0 is even and why not it is odd number? Now think about the pattern of whole numbers and pattern of even numbers. We find that even numbers are equally spaced. That means if you want to find the successor of a even number, say for example, what is the successor of 10 which is even, you find 10 plus 2 equal to 12. That means the even number after 10 is 12. Then what is the even number before 10? 10 minus 2 equal to 8. Then what is the even number before 8? 8 minus 2 equal to 6. 6 is the even number before 8. What is the even number before 6? 6 minus 2 equal to 4. What is the even number before 2? Before 4? 4 minus 2 equal to 2. Now what is the even number before 2? Can we find the predecessor of 2 which is even? Let us subtract 2 from 2. 2 minus 2, 0. This is a whole number. That means 0 is a whole number. The predecessor of 2 which is even, how will you find it? 2 minus 2 equal to 0. 2 minus 2 equal to 0. 0 is a whole number. Whole numbers are starting with 0. So 0 is a even number. Now 0 is not odd number. Odd numbers are equally spaced the same way the even numbers. The predecessor of 7 which is odd number, you will find that 7 minus 2 equal to 5. Then what is the predecessor of 5 which is odd number? You again subtract 2 from 5. 5 minus 2 equal to 3. Now what is the predecessor of 3 which is odd number? 3 minus 2 equal to 1. Now what is the predecessor of 1 which is odd number? We'll try to find it. 1 minus 2. 1 minus 2. 1 minus 2 means you count 2 steps backward from 1. One step, then another step. Now imagine there is a number 2 steps backward from 1, 2 steps left from 1. Now whole numbers are starting with 0. Now can you find a whole number in this place? No. That means predecessor of 1 which is odd number, it is not a whole number. It is not possible. It is not a whole number. Hope you understood why 0 is even number and not a odd number. Now let's discuss some more properties of whole number. Let's think about another set of whole numbers. Say for example 2 equal to 1 multiplied by 2, 3 equal to 1 multiplied by 3, 5 equal to 1 multiplied by 5, 7 equal to 1 multiplied by 7. This set of numbers 2, 3, 5, 7, etc. They have only two factors. One is the number itself, another is 1. This type of numbers are called prime numbers. They are called prime. Now what is prime number? A prime number is a whole number which have only two factors, 1 and the number itself. Similarly 11 equal to 1 multiplied by 11. It is a prime. 11 is prime. 11 has two factors, 1 and the number itself. 13, similar way, 1 multiplied by 13. It has only two factors, 1 and 13. Now if 1 is a prime number, if 1 is a prime number, you see 1 equal to 1 multiplied by 1, it looks like it has two factors, but it is a repetition of the same number. That is why 1 is not a prime number. 1 is not a prime number. Now there are another numbers. Say for example 4 equal to 1 multiplied by 4, 2 multiplied by 2. So factors of 4 are 1, 2 and 4. Similarly 6 equal to 1 multiplied by 6, 2, 3 is 6. So factors of 6 are 1, 2, 3 and 6. Then factors of 12, 12 equal to 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. So factors of 12 are 1, 2, 3, 4, 6 and 12. Now this type of numbers which have more than 2 factors are called composite numbers. Composite numbers. That means the whole numbers which have more than 2 factors are called composite numbers. 6 has more than 2 factors. 6 has 4 factors. 12 has how many factors? 1, 2, 3, 4, 5, 6 factors. That means more than 2 factors. These are called composite numbers. Now we'll discuss another set of numbers. Say for example 4 and 5. Now 4 is a composite number. 4 is composite. And 5 is prime. 4 factors of 4, 1, 2 and 4. And factors of 5, 1 and 5. We see that 4 and 5 has only one common factor. 4 and 5 has only one common factor. 4 and 5 are called co-prime. Although 4 is a composite number, 5 is a prime number, we call them co-prime because they are relatively prime. They have only one common factor, that is 1. Similarly, 8 and 9, you see factors of 8, 8 ones are 8, 2 fours are 8. Factors of 9 are 1 nines are 9, 3 threes are 9. Now factors of 8 are 1, 2, 4 and 8. Factors of 9 are 1, 3 and 9. Now common factors of 8 and 9. 8 and 9 is only 1. That is why 8 and 9 are co-prime. So what we have learned, co-prime numbers means a pair of numbers whose common factor is only 1. Now let us check whether 15 and 18 are co-prime. Now find the factors of 15. 1 multiplied by 15, 3 multiplied by 15, 5. 18, factors of 18, 1 18 is 18, 2 9 is 18 and 3 6 is 18. Now common factors of 15 and 18. What are the common factors of 15 and 18? 1 and 3. So this pair of numbers 15 and 18, they have two common factors, and they have common factors other than 1. This is 3. Other than 1. That is why 15 and 18 are not co-prime. They are not co-prime. Now let's discuss another pair, 20 and 21. Factors of 20, you find 1 multiplied by 20, 2 multiplied by 10, 4 multiplied by 5. Factors of 21, 1 multiplied by 21, 3 7s are 21. Now what are the common factors of factors are 1, only 1. common factors of 20 and 21 is only 1. Therefore, 20 and 21 are co-prime numbers. We will discuss some more properties of whole numbers again, and this much only for today. Thank you.